Electronic Specifier.
Welcome to Electronic Specifier Insights, the podcast for electronics engineers. I'm your host, Paige West. In today's episode, I speak with Jaime Alcantara, Senior Product Manager at Sonatus, about how over-the-air updates are evolving for software-defined vehicles. The automotive industry is rapidly shifting towards more software-defined vehicles, and Jaime walks us through some of the latest advancements in the technology and how Sonatus supports over 2 million vehicles. I hope you enjoy this episode. Let's get started.
Electronic Specifier.
Today, I'm pleased to be joined by Jaime Alcantara, who is the Senior Product Manager at Sonatus. So thank you very much for joining us today. And how are you? Are you well?
Hi, Paige. Yeah, thank you so much. Thanks for having me here. Everything is going well. A little bit early here in California, but otherwise, everything going great. Thank you.
Good. Well, I'm just finishing my day here in the UK, so I'm pretty glad of that. But before I log off for the day then, why don't you tell us a little bit about yourself and your background?
Sure. So, as you said, my name is Jaime Alcantara, engineer as a background. I've joined the company I'm currently working at, Sonatus, about 5 years ago. And before that, I was actually working from Germany for Mercedes for about 10 years.
Excellent. And can you tell us a little bit more about Sonatus as well? You know, what is the company? What is it you guys do?
Sure. So Sonatus provides in-vehicle cloud software for the automotive industry, and we help OEMs transition to the software-defined vehicle. So we have different products that enable them to do data collection, networking, cybersecurity, over-the-air updates, as well as like automations.
Excellent. And the main focus of our conversation today is going to be around the software-defined vehicle and more specifically how over-the-air updates are evolving for these software-defined vehicles. But firstly, can you define for us what exactly a software-defined vehicle is and what it means?
I think that's a great question, and we've heard that a lot. It's a tricky one because I think different people understand different things about what a software-defined vehicle is. For some, it may be just a vehicle that can do over-the-air updates. For others, it's just hiring a lot of software engineers, and then you start having like a software-defined vehicle. But for us, it's really making the vehicle as configurable as possible. So the term was really coined a few decades ago in the networking industry with software-defined networks. And what that really means is that you have a network that you can like continuously configure. And that's what we're trying to apply on the edge, like on the vehicle side. So trying to make everything that you put in the vehicle as configurable as possible so that even after production, you can still tweak the behavior of the car without needing to change any components and things like that.
And following on from that, what would you say are some of the biggest challenges that automakers are facing at the minute in this transition to software-defined vehicles and over-the-air updates?
I think there are different phases or like different perspectives that OEMs are challenged with when transitioning to software-defined vehicles. On one side, OEMs are very mechanical based from nature. So they've been trying to build like this know-how of like how software works, but that transition is also going slowly. And especially with software-defined vehicles, it's something that just like takes some time to get there because you have to find the right talent. Depending on where you're based, that's easier or more difficult to do. On the other hand, when we talk about software-defined vehicles, we're talking about very complex software systems. So like in the 1980s, when like the CAN bus was introduced, that was kind of like the only networking technology that was out there, right? So everything was like AUTOSAR based, microcontroller based, and things like that. But over the years, the whole architecture of the car has been evolving to include like high power computers, and we now have like a lot of rich operating systems in the car. There is like the Linux, there is like the real-time operating systems, there is the Androids and those kind of things. So all these things now live on like hypervisors using virtual machines. We start seeing containers. So from a software perspective, it's becoming much more complex to handle because of like all these structures that are being introduced with the usage of like rich operating systems and advanced networking technologies.
I'm interested because, to the best of my knowledge, over-the-air updates started as a way to fix software bugs remotely, right? But now they offer way much more than that. And I was at CES back in January, and there was a lot of innovations in this software-defined space. So I'm interested to hear from your point of view. What are some of the most exciting advancements in over-the-air technology at the minute?
That's a good question. If you take a look at the market, as you said, like over-the-air updates are being used a lot to do bug fixing. So whenever we hear that there's been a recall in the market, that doesn't explicitly mean that the vehicles actually go back to the workshop or things like that. A lot of those things today are being fixed with an over-the-air update. I think I even read recently that one of the Tesla recalls recently involved about 700,000 vehicles with the TPMS system was actually done via an over-the-air update. But it not only considers that. If you think about like back in the day in the 2000s, when we had like all these cranky navigations in the vehicles, some of those were already being updated over the air, just like on a much slower pace, maybe like once every 2 years, whenever the map provider would release a new map. But that has evolved a lot. And I think today, over the updates are being used to update and provide new features to the users. So over-the-air updates are being used to release performance updates to the engines, new charging patterns, changing algorithms in ADAS for like object detection and things like that. So they're really trying to incrementally add value to the vehicle. And this doesn't explicitly mean that the value is added and then the user has to buy it or something like that. A lot of that is about improving emissions, improving performance, extending the longevity of the batteries, especially in EVs. So over-the-air updates are really introducing additional value to the vehicle. They're introducing personalizations, making the vehicle more tailored to the users and they're being driven and things like that.
Now, I know that Sonatus supports over 2 million vehicles. So can you share some examples with us as to how your over-the-air solutions have improved vehicle performance or customer experience?
Sure. So I'll try to not share any of our customers' kind of like private proprietary information. But when we started developing our solutions, and I just take like data collection as an example, we envisioned the product and we created the product. We developed this product with configurability in mind. So if you wanted to collect certain types of vehicle data with different events, for example, when it's braking, when it's raining, in an accident, or in something like very specific driving patterns, you could define those via policies. So all those data collection behaviors, though they're not directly experienceable by the user, they are for the OEM engineer. So when we're talking about like 2 million vehicles that are being updatable, taking like this data collection as an example, they can change the behavior of that data collector at the edge dynamically using policies. And policies is just what we call one asset type. So firmware is another asset type, but policies is a very tiny configuration file that is sent to the vehicle, has a very low footprint. So that has been used a lot in terms of diagnostics to allow OEM engineers to actually troubleshoot vehicles remotely. So you don't want to have like a continuous data collection of unnecessary data running all the time. You want to deploy that only when it's needed. And one way to do that is with these like policy updates, which is just one branch, you can think about it, of what our updater, that's what we call our OTA solution, actually supports.
And I guess the problem is that many automakers still rely on legacy architectures. So sort of coming back to the challenges question that I asked earlier, what are the biggest limitations of older vehicle platforms when it comes to OTA updates?
I think a lot of it is caused by how the ECUs have been developed. I think like OTA updates in the past weren't like a must-have for very basic ECUs. Therefore, those ECUs weren't really updatable over the air. They didn't support that feature. So a lot of these OTA updates were really constrained to like the IBI only, right? Like it started with the maps and it stayed in the maps for a very long time. But when we think further ahead and we see how much an update can actually change, for example, how a seat movement is, right? Where like maybe users are complaining about like, oh, it's too clunky, it's moving too fast or too slow. You could use an over-the-air update to actually change the behavior of that, given that it behaves in a still safely range. So I think what OEMs are now coming to realize is that over-the-air updates have a lot of power, and they're making this a requirement in all the new architectures that if not all, almost every ECU in the vehicle needs to be updatable over the air. So it's extending past the IVI and the ADAS towards like door modules, seat, integrated body controllers, connected ambient lights, and so on. And that's just like opening the possibilities of how a car can actually change after production tremendously.
And how is Sonatus specifically helping these OEMs bridge that gap between the traditional vehicle architecture and the needs of these modern software-defined platforms?
So on one side, we've been building our solutions like from ground up. We've been watching how the industry is evolving over the last 20 years. We've seen how these kind of things have been done in the data center industry. And we've taken a completely new approach to it. Basically, we don't only focus on firmware, which is what used to be done in the past. Just like you can think about like the firmware updates, like your big cannon to like shut everything that you can do with it, right? But that's not very precise, and depending on the update, it could be actually very bandwidth consuming. So what we're doing is we support multiple software assets. I talked about this in the beginning with like firmware, virtual machines, containers, and so on running in the vehicle. So the more precise you can get, the more controlled that update will be. And that could be like either changing some parameterization, changing some variant coding, configuration file application, and then ultimately, yes, you can still use the firmware. But what our solution allows is really to target each of these things precisely. So you can think about it as like you are a surgeon, right? And the more tools that you have available, the better expertise you have in that field, the better that surgery would actually go. And that's where we are trying to give OEMs. So another point in that is for example, troubleshooting. Troubleshooting a vehicle is extremely hard. And just to stay with like the medical example, it's like when you go to the doctor and it's like, oh, I have, my throat is hurting, right? Just by looking at the throat, you can do some high level analysis, but if you can do a swab and things like that, then you can actually have much more detailed information. Our OTA solution does that. Like you can think about it like a fingerprint ID to every OTA rollout that's out there. It gets passed from the cloud to the vehicle to the individual ECU, each individual software process level, so that you can like backtrack if something happens, what was actually that went wrong. Because especially with OTA updates, you don't just want to have like breaks in the road, right? We've seen that where suddenly someone deploys an OTA update and like 20,000 vehicles are not starting. So we want to avoid that at all costs. And we want to give OEMs the tools necessary to avoid such kind of behaviors.
And something else we need to touch on as well is cybersecurity and how that plays a role in the software-defined vehicle. I think over the last couple of years, there's been a few stories about third parties hacking into vehicles and using them in malicious ways. So how does Sonatus ensure cybersecurity and how can we prevent potential hacking threats?
That's a very good question. And it's going to become even predominantly more and more important, especially if you think about like autonomous vehicles and things like that. There was a recent news about a Waymo being hacked where the LiDAR was showing some LED patterns. That should be avoided. And especially with over-the-air updates, that is point of entry for hackers, right? Because they could always try to tamper with the firmware. So there are different standards in place that OEMs and Tier 1 should follow in order to make sure that the solutions that they develop are actually cyber secure. We're following all those, some namely ones like ISO 21434, Optane framework, and then as well, OEMs need to be compliant with UN regulations like the UN R155 and UN R156 if they want to sell in specific markets. And for them to be compliant with that, we have to provide the necessary proof that we have done everything in our hand to make our system as secure as it could be, for example, by signing the packages and encrypting them before sending them to the vehicle, using HSM modules, which are embedded in the hardware to kind of like decrypt and make sure that the packages that are being downloaded are legit and cannot be tampered with. Because no one can avoid, or no one wants to go into the risk of receiving a bad update, right? And one that has been tampered with over the year.
Mm. So looking ahead then, what new features or capabilities do you think will become standard in OTA updates over the next 5 years?
I think a very big trend that we're seeing in the industry is all this kind of like shift left from the B cycle. So what that means is that a lot of OEMs are trying to test and validate what they're doing before it actually goes into production. So we're seeing a lot of like virtualized environments. Our demo at the CES was using one of those as well. Like we had a Android automotive virtual IVI system running on AWS with one of our partners. And our whole OTA pipeline was using that as a target for OTA update. So being able to do those kind of things, kind of like securing and testing what will happen in the real world before the real world is even available is a very big trend, kind of like integrating with the CI/CD pipelines of the OEMs, but also especially predicting what the outcome of such a behavior will be. So our solution also has, like, for example, dry runs where we give OEMs transparency about the impact of an update, like, oh, how long this update is going to take for each individual car, how much bandwidth is it going to consume, so that if I'm the operator, I'm trying to push an update and it's like, oh my God, this is going to cost like $3 million or pounds, right? Then, oh, maybe I'll think it twice and maybe this is an update that's only going to be available via Wi-Fi. Mm. So trying to give OEMs the visibility into what's going to happen when you actually press the button is incredibly important. And then there's also AI, right? We're seeing the tremendous developments that's causing and how much it's helping. We believe as well that that's going to be a major keystone in any further development. This year, we also had like 3 demos related to AI where we're also being the first to come to the market with such solutions, and it's going to update, or it's going to impact the over-the-air updates as well.
I'm glad you've mentioned AI, because I was going to ask a question around that, and I'm intrigued do you think we'll ever get to a point where vehicles autonomously optimize their own software and performance?
I would think, or I would like to think that we'll get there at some point. I still think that AI still needs a lot of like hand holding. So you still need like some sort of like human in the loop where AI may do the first set of recommendations in terms of like updates that a vehicle could need. But there's still going to be needed a human that actually validates what the AI is proposing and making sure that that update is actually needed and can be pushed to the right vehicles, because you just don't want to let an AI just decide over a fleet of like 50,000 vehicles what update it needs to do and how it's going to do it. You could end up with a lot of surprises, a lot of them not specifically positive. So I think AI can help in a lot of ways in troubleshooting, in planning, and things like that. But we're just like at the verge of it. We have to take it with a grain of salt and kind of like handhold it a little bit so that it can actually provide the value that it can promise.
Yeah, definitely. It does paint a very interesting picture of the future, just imagining all of these cars updating themselves autonomously. Very sci-fi.
Yeah, absolutely.
Brilliant. Well, thank you very much for your insights. It's been a great conversation. Is there anything else you wanted to add before we sign off?
No, thank you. It's been a pleasure talking with you. So extremely eager to hear this and any future podcast. And thank you for having us again.
You're very welcome. It's been our pleasure. Thank you very much.
Awesome. Thank you.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry.
Electronic Specifier.